Alright, to make our model, we have a shoebox here that we painted with black paint, and we cut off one of the sides and the little things that come along that are along the top. So you can shut it like this and it looks all pretty. Anyways, so this is a piece of cardboard that we also painted black for the roof of the pyramid. So, and then our pyramid here is painted cardboard that I used classic instructions to make the square and the sides to make it a pyramid. And it's filled with Play-Doh to give it some weight. And then there's a string running through it, so you can hold it with the string. And we've got these little, and the box we got from Joann Fabrics, and we painted it red to represent the lava pit. And there are fuzz balls in there to represent the lava. And then we've got some other decorations in here to make it look like a tomb. So how the problem works is the pyramid is up here, and Indiana Jones walks down the stairs and he skirts the lava pit, and then he starts to fill his pockets with treasure. But wait, the ceiling falls out! So what happens is you move, and then the pyramid falls slowly, exaggeratedly slowly, into the lava pit. Indiana Jones saunters confidently into a tomb. Just inside the tomb is a 30-meter tall, solid gold square pyramid with a base length of 5 meters. Indiana Jones walks down the stairs and sees a large lava pit with the treasure he desires on the other side. He skirts the edges of the lava pit and begins to fill his pockets with the treasure's coins, but alas, the ceiling caves in on him anyway. The pyramid falls into the lava pit and starts sinking at 5 meters per second downwards. When the pyramid has sunken in 10 meters, at what rate is the pyramid's volume decreasing?
So to find the rate at which the volume is decreasing, we first have to know the volume formula for a pyramid, which is 1/3 of the area of the base times the height. And since the base is a square, we know the area of a square is the base squared. So the volume formula becomes 1/3 times the base squared times the height. Now you're going to take the derivative using the product rule, which becomes dv over dt equals 1/3 times 2b db dt times h plus 1/3 b squared times dh over dt. Then to find the base, which is what we're missing, we use this ratio of 30 over 5 set equal to 20 over b, with 30 and 5 being the original height and the base. And then 20 is the height because when it decreases at 10 meters, the height is 20 meters. Then we cross multiply and then divide and get a base of 3.33 meters. And then we plug that in right here. And now we have to find dB over dt, which we have to do another ratio of 30 over 5 set equal to height over the base. Cross multiply again, and you get b equals 0.166 times the height, and then you take the derivative of that to get the rate of change, and you get dB over dt equals 0.166 dH dt, and then you go over and plug that in to the equation, and then you have to plug in dH dt, which is given, and it has to be a -5 here and here because it's decreasing. And then you solve and you get a rate of change of -55.6 meters cubed per second. QED.